All right. So we have talked about SIP protocol, signaling protocol. Next is H323. H323 is another signaling protocol. We also discussed about it, both SIP and H323, its advantages and disadvantages. H323 is also another open standard protocol, but SIP is more commonly used. H323 can also be used. It has some advantages and disadvantages on its own. We will see some components here. So H323 network components are these. H323 network can have H323 terminal. Terminal means the H323 endpoints. There is Cisco gatekeeper. Cisco gatekeeper means the one that is using the information to send to the gateway, right? Then we have MCU, multi-protocol control unit. We have some components like we have routers, we have Cisco proxy, we have real-time network tools, we have gateways, we have terminals like or endpoints like ISDN terminal, and like that. So this is what the S323 network components are. So routers can be used as a voice gateway here in S323, so it can be a gateway. S323 endpoints can be registered on VCS server, but not on call manager. These endpoints in H323 are not registered on call manager. We can register the endpoints on call manager using SIP, but not H323. S323 methods are two methods that we will discuss. But before that, this is what I want to share, that these are the components of H323. We have H323 terminals. This is just a term used for S323 endpoints or S323 terminal, you can say. Cisco Gatekeeper is used to create a centralized plan or create centralized dial plan. Then we have MCU. MCU is not used anymore. This is a hardware resource. Which is used for call processing. It's also used for conference bridge. It has RAM and so on. So nowadays, instead of MCU, there is TMS used. Sorry, CMS used, Cisco Meeting Server. Okay, so this is what MCU is used for. Then we have router as the gateway. We can use Cisco proxy as we discussed about the proxy server. We have gateways and we have some endpoint devices like H320 terminal, H324 terminal, H323 phone. So basically what these different parts of information or signaling is, S323 itself is not a protocol. Like SIP is a protocol. H323 is not a protocol, it is a framework which use different protocols. Like we say in VPN, VPN is not a protocol, or IPsec is not a protocol. It uses a group of different protocols to work for authentication, for authorization, and so on, for encryption. Similarly, H323 is a framework that use other protocols and other algorithms for it to work. Protocols used are the protocols used in H323 are H225, H245, Q931. These are the protocols. Okay. And H323 is the framework. H225 and Q931 are used for call setup, whereas H245 is used for capabilities negotiation. Here and write it somewhere. It's important. So H323 is a framework, whereas the protocols are H323 framework that uses protocols and algorithms. And the protocols are H225, Q931. These two are the protocols used for call setup, and H224, sorry, 245 is used for capability exchange or capabilities negotiation. Okay, so these are the three protocols. Okay, this is also important for exam perspective. You should know. All right. So there are different H323 call flow methods. There is slow start method and there is RAS method. So slow start method is in which there is these protocols being used that we just discussed, H225 and Q931 for call setup, and H245 for capabilities negotiation. So whenever a call is being initiated, let's say one PSTN phone is calling the other one, or any, it can be from headquarter to PSTN, PSTN to headquarter, or so on. So when the call initiates, it will send a call setup message and a call proceeding message. So like we discussed different types of messages in SIP also, like invite, okay message, acknowledgement, bye, and so on. Same way in H323, there are different types of message exchange. So there is this is the steps that happens. First, the call is initiated. So initiate call, then call setup. Call setup is done by these protocols H225 or Q931. Then call proceeding is received from the destination. Then the call started ringing on the called number. It rings called party. In response to it, an alert is being sent back so that the initiator gets a ring back tone. Okay? So that is the next step. Once the ring back tone is received, it is now waiting for the destination to answer. When the destination answers the call, it will send a connect message back. The ring back tone will stop now. Then capabilities exchange will happen. Master slave determination will happen. Now that depends on the capabilities. So whichever device has the superior parameters or capabilities will become the master, other will be the slave, and depending on that, a determination is done and a channel is open. So it opens a logical channel. This is where the session establishment is taking place. Once the session is completely established, capabilities exchanged, master slave determination, and the logical channel is built, then the RTP comes in and the media is being exchanged, and the media is exchanged using RTP. There is RTP stream and RTCP stream going on between the two endpoints. So this was slow start. Next is RAS. RAS stands for Registration Administration Status. Registration Administration. These are different words which just simply tells you these are the different steps in this call flow. Administration status. Okay, so two H323 methods are slow start, like we discussed about early offer and delayed offer. It's just the same thing here, different terms are there. There were some messages types here in H323 are some messages type or different steps, right? So another method is H323 RAS call flow. RAS is registration admission status. So these information is being exchanged in this method. So two types of steps are there in RAS call flow. There is A R ARQ and there is ACF. ARQ stands for admission request. So initiator sends the admission request, and ACF is admission confirmation or admission confirm. Okay, it's written over here also. ARF is admission request. ACF is admission confirm. Okay, so in this case, what happens is when the call is initiated, it will initiate a call. An ARQ is sent. ARQ is admission request. So it just says, okay, please give me admission. Please allow me for this call session. And then the destination will say, okay, I confirm your admission. Now you can, let's it's like a student asking for admission and the principal says, okay, you got the admission from tomorrow. You can come and join the session and join the college. Same way here, it's the initiator requesting for admission and getting a confirmation. Once the confirmation is received, it can go ahead and set up the call. It can send a request to set up the call. Then from the other side also, it is a two-way process. So ARQ and ACF will be sent to the other party also. For this call setup, again, the same protocol, H225 or Q931 is used for call setup. These will be exchanged once from both the sides, the ARQ, ACF messages have been exchanged successfully. The call setup will be done successfully and it will go ahead and ring the called party. Once it is ringing the called party, it is sending an alert message and the initiator is getting a ring back tone. Once it is being answered, it is sending a connect message, ring back tone stops, and the connection is established. It will now go ahead and exchange the capabilities. In the exchange of capabilities, the protocol used is H245, which do the capabilities negotiation based on which a master slave determination is done and an open logical channel is built. Once that is done, an RTP stream is built and the communication between the two endpoints is happening. So this is a little difference. Like here, there was no requirement of a two-way admission request. It was just from the initiator end, and once the call is being set up, it will be built and the capabilities will be exchanged and RTP stream will be established. Whereas in RAS, there will be a request and confirmation required from both the sides. And once that is done, then the same steps is followed. The things to remember here are the protocol types like call setup protocols H225, Q931. Make sure that you do not confuse these protocols with H323, which is not a protocol, is a framework using these protocols. H245 is the protocol used for capabilities negotiation. So a group of protocols is being used for H323 to work actually. Okay, so as this is one of the protocol, now this is the protocol H245, which is used for media negotiation. What it does is it do a capability negotiation, master slave determination, and logical channel signaling. Okay, so these are the functions of this protocol. The terminal capability set TCS is used here. It is TCS is a short for terminal capability set, in which the negotiation of codecs and VAD is done. Codecs we know already, so codec exchange or capabilities negotiation is done. VAD is voice activity detection. Voice activity detection, VAD. So terminal capability set has codec and voice activity detection. Then there is an open logical channel which takes care of RTP and RTCP ports. Okay, in H245 media negotiation. So now we are seeing, like, digging deep into what this media negotiation protocol is actually doing. So here there are some more detailed messages types: TCS request, master slave request, TCS request from the other side, master slave request response from the other side. So it's a two-way process now. TCS plus master slave acknowledgement and TCS acknowledgement. Master slave acknowledgement. So every message is being sent and received from both the sides, the request and the response, and the acknowledgement as well for each packet or each message. Then there is OLC message. OLC stands for Open Logical Channel. TCS we discussed terminal capability set, in which there is codec and VAD. Open Logical Channel has information of RTP and RTCP ports to be used. So the request will be sent for Open Logical Channel from both the sides. It will negotiate and use one of the port number for RTP and RTCP. Acknowledgement and response will be sent and the media RTP will be established. Now, in H323, there are fast start and early media. So we discussed about fast start and two methods. There is slow start, fast start, or RAS, registration administration status. So we have fast start and early media, like we discussed in SIP. If you have any media uh, to be retrieved before the session actually establishes, then what happens is when a call is initiated, a call setup message is being sent. For call setup, H225, which is a protocol, is used, which will be a call setup message carries multiple H245 TCS and OLC messages in combination based on the number of codecs. Then the call proceeding message will be sent. Then H225 call proceeding message carries confirmation for one TCS variant and OLC information. So now the information being sent by the initiator is being exchanged to the other. Then once this is done, the negotiation is done between both the TCS and OLC have been successful. The codec, WAD, and the RTP, RTCP information is being negotiated. Then what happens? It will start ringing. The called party will ring. It will send an alert, get a ringing or ring back tone. And when the call is answered, it sends a connect message. Once that is done, then the RTP comes in and takes care of the one-to-one communication between the endpoints. Okay. Once the RTP stream is built, then what happens is it will send a ringing called party if. Now, this is when early media allows streaming of media like announcement, music on hold before the call is actually accepted. So in that case, RTP stream is built, but now because we have additional media like some announcements or music on hold before the call is actually accepted, so, for example, in the customer care office, like I took the example before, it asks you to put some inputs. So, based on the inputs, then it will be answered. So, call is actually being connected. The RTP stream is going on, but it has to be answered via another media. So, then there will be another method after that, some additional step. It will now start ringing based on the input provided. And same way, it will send an alert and then it will ring back and get connected. In ST23 also, like SIP, we discussed about DTMF relay, like in this example for IVR, when you're giving some input. So RTP packets and audio packets are there. RTP and audio packets comes in the same packet in the in-band audio in ST23 also, and separately in out-of-band signaling. Now, SIP versus HT23 for intercluster trunking. So, when there is an intercluster trunking, what are the different features of SIP and HT23? So, where support for additional characters in SIP there is, in HT23 there is limited. Signaling authentication and encryption is supported in SIP using TLS, and limited support for authentication and encryption in H323. Media encryption is there in SIP as well as H323. It runs on all nodes, both. Up to 16 destination addresses are supported for both SIP and H323. Options ping is supported in SIP but not H323. SME clustering over WAN with extended round trip times is supported in SIP but not H323. Support for the codecs like G711, G722, G723, G729 is for both. Continuing this, some other features like SIP subscribe, notify, publish, presence, these information is there in SIP but not H323, not all of these. Except audio codec preferences in received offer, SIP does that but not H323. URI call routing global dial plan replication is supported in SIP but not H323. So when you have to do like URI call routing, when you have to make call based on some unique resource identifier, URI URI. You want to make calls using URIs. That is supported in SIP but not H323. Although for URI, you have to make sure that the endphones are also. You are right. Global dial plan replication, if you have, let's say, different clusters. So you have, let's say, on the headquarter, one cluster, on the branch, another cluster of CUCM. And by default, there is no intercluster replication. The replication is within the cluster or intra-cluster. So if you want to make intercluster replication, that is what global dial plan replication is. That is supported in SIP, but not H323. Then IPv6 dual stack ANAT is supported in SIP. So for IPv6 networks, IPv6 technologies, SIP is a protocol that is recommended, and H323 does not support that. BFCP for video sharing or video desktop sharing, SIP can be used, H323 cannot. So SIP is more advanced. We can see here a lot of advanced features and capabilities it has, whereas H323 has limited features. Now, for connecting to iOS gateways, some features comparison is this. So the centralized provisioning is supported in MGCP only and not SIP and H323. So when you're connecting to iOS gateways for gateway protocol, MGCP is used for centralized provisioning. For centralized call detail records, again, MGCP is used. SIP, H323 are not used for those purposes. Tunneling is supported for H323 MGCP for tunneling. ISDN overlap sending is supported in MGCP and limited in H323, but not SIP. So here we can see these are the things that SIP does not support and not cannot be used for, like centralized provisioning, tunneling, and so on. Accept audio codec preference in received offer. So to accept audio codec preferences or information, it is supported in SIP, yes, but not in H323 and MGCP. SIP runs on all nodes, whereas H323 and MGCP does not. Up to 16 destination addresses are supported for SIP, but not H323 and MGCP. They have limited support for the destination addresses. SME clustering over WAN with extended round trip times is supported in SIP, but not H323 and MGCP. Also, options ping, TCL, apps like CVP integration, IPv6 dual stack, NAT, ANAT for natting between IPv4 and IPv6, that is supported by SIP, all three, not by H323 and MGCP. Now, troubleshooting tools. As for SIP, H323, we can use different troubleshooting tools like RTMT, Translator X. These are some tools names, Wireshark, Collaboration Solution Analyzer. These are the different troubleshooting tools used for troubleshooting SIP and H323. So RTMT, we have already used RTMT in the labs earlier also. We will use it here also. So for troubleshooting purpose, we can use RTMT. We can use Translator X, which is another tool. Wireshark, of course, Wireshark is very commonly used for troubleshooting, for analyzing the packets and messages. Collaboration Solution Analyzer is also one of those. So Cisco Expressway, Cisco iOS Gateway, Cisco Unified CM and SME, they support different types of troubleshooting tools. Like RTMT is supported by CUCM and SME only. Translator is supported by all Expressway, iOS gateways or CUCM. Wireshark is supported by all. Collaboration solutions are supported by all, which requires packet capture. So these ones are for packet capture, as we know Wireshark does. All right.